Okay, hello students. So we are back here with the gamma ray scintillation setup here. So I have the detector in the background here, and there's a Cesium 137 puck right there on top giving us some good hits in the detector. And if I go down to the oscilloscope here, you see the usual gamma ray amplifier signal output coming in here. So a variety of pulse amplitudes coming in, and if I lower the trigger level just a tad bit, you can see indeed all of these different amplitudes you see in there are the different gamma ray energies coming in. If I run the oscilloscope sort of in single mode, you can see the pulse height change as the oscilloscope triggers. Again, indicative of different gamma ray energies that are ultimately detected by the detector. And of course, the signal that I'm looking at is coming right out of the amplifier right here. I have the amplifier set at about 50 or so, and here's the input right here from the detector, and the output is going rather through this cable right here on in the oscilloscope. So we have our usual scintillation setup done. What I'd like to do in this video is show you a new NIM module. It's called the single channel analyzer. And let me tell you how it works by way of the oscilloscope. So when we look at the oscilloscope over here, of course, as we said, all these different amplitude pulses coming in here are indicative of different gamma ray energies that are ultimately detected by the scintillation detector. And what I can do to introduce the SCA is if I start turning the trigger level on the oscilloscope, you can see that the trigger level basically is this horizontal line you see down here on the oscilloscope. And what the trigger level is, of course, is whenever a voltage exceeds this level. So when a voltage goes above that line, it tells the oscilloscope to sweep across and refresh its display. So you can see when the oscilloscope trigger level is set really low like that, we see pulses all the way down to almost the baseline level appearing on the oscilloscope because the oscilloscope is allowed to trigger on very low voltages like that. So in other words, when this line is very close to zero, or the baseline like that, it seems like any little pulse that comes in is going to cause the oscilloscope to trigger and sweep across. Now, as I start raising the trigger level up and up and up, you can see that we start to get this empty zone down in here where the gamma ray amplifier output may be, but it's dark right there because the trigger level is too high in this region. See, the trigger level is way up here now, and anything that comes in below this level is not going to be triggered on or displayed on the oscilloscope. So we're sort of discriminating out some events that might otherwise be visible on the oscilloscope. As I keep raising the trigger level up and up and up and up we go, see that it just gets really empty down here because you saw where that horizontal line was, that trigger level right there. Everything below that line won't cause the oscilloscope to refresh its display and sweep across, and so we don't see anything in there. And if I go all the way up to the top like this, you can see we can really discriminate out all except the highest energy gamma ray pulses coming in. Look, it's almost entirely empty there now because everything below this trigger level is just too low. The oscilloscope won't trigger, won't refresh its display, and you won't see it. So it turns out being able to set a level like this on the oscilloscope is a kind of fun thing to play with. It isn't overly useful at the moment. It's very useful for oscilloscopes, but it's not useful for nuclear counting because we're just sort of changing the display that we ultimately see on the screen right there. But it turns out that this functionality of setting a voltage level and having the equipment only respond to voltages that exceed that level are all encapsulated into another NIM module that I have here in my hand called, I don't know if it's going to focus on that, called an SCA or single channel analyzer. Okay? So let's pop it into the NIM crate like this. So remember, this is the amplifier, this is the high voltage power supply that we've been using all this time. So just going to pop it in here, give it a good push. We'll leave those screws loose just for the moment there. And what we see on the single channel analyzer are inputs as follows here. I'll give you a rundown about how this works. Okay, so the first thing we see here is an input. And this input here will be an input like that. It'll just be the voltage coming out of the amplifier. And this output labeled here, SCA out, stands for single channel analyzer out. So SCA, of course, stands for single channel analyzer. This is the output here. Then if we look up here with the knobs, I don't know if you can read the writing on the video here as I have it. This one says lower level for this knob, and this knob here says window or upper level. So let's see exactly what the SCA does. I'll hook it all up and show you in the next video because I think this video is running a tad bit long, but let me just describe the functionality of the SCA. We send an input into the SCA. The input's going to be basically one of those voltages there. So we're going to tee right off the amplifier with this cable right here that I have sort of set up right here is teed off the amplifier. This is going to go right into the input of the SCA. So what we're going to do is we're going to send that sequence of varying pulse heights right into the SCA on his input right here. And then what we'll do, at least for the sake of looking at the demonstration here at the moment, is we'll take another cable here and we'll run that into the oscilloscope. So we'll take this cable here and put it on the output, and we're just going to run that right into the oscilloscope. I'll get it hooked up for you in the next video. And then what we can do after that is when it's hooked up, then we can start turning the lower level and upper level knobs. Now, what the lower level knob does is a lower level knob, we can't see it on the oscilloscope because it doesn't have outputs like that. It would be useful if it did, but we can't. The lower level is essentially a line like this, analogous to the oscilloscope trigger, but it's only a line that's internally recognized by the single channel analyzer, internally. So we're lower level. That means internally to the SCA, we can turn the knob here and set a line that represents a discriminatory line. Every voltage under the line will be ignored. Every line above the line, the SCA will react to. Furthermore, the top knob right here says window or upper level. We can actually set another line above the lower level to sort of cause like a little window to appear, something like hold your hands parallel like that. And if a voltage coming into the SCA appears between my hands, in other words, appears within this window here, within this window, this SCA will react. Any pulses that are outside this window will be ignored. And so what the SCA is, a single channel analyzer, allows you to take in a single channel, which is just an analog voltage here, and allows you to discriminate if you want to react on that voltage or not. Okay? So in the next video, I'll show the SCA all hooked up and operational.